Agisoft Metashape Professional offers functionality to generate drone flight plans for objects with complex geometry. This tutorial describes basic workflow steps to create the optimal route for a drone with the help of Plan Mission tool and eventually to generate a good quality model to the target object. The workflow consists of 3 major steps: capturing images with standard overhead flight, creating detailed flight plane based on rough mesh model, and performing image capture according to the planned waypoint mission. For best experience in terms of safety and precision, we recommend using RTK drones. They allow performing flights as close as at a distance of 2 meters from the surface with a centimeter accuracy positioning. You will also need a laptop for on-site processing and plan computation. When capturing complex buildings in manual mode, it is easy to miss some parts of the surface. Automatic mission planning allows to ensure complete coverage, while avoiding user-specified zones and automatically detected objects like trees and power lines. We will demonstrate the workflow related to an RTK drone. If you use mobile RTK station instead of NTRIP network, mount it in an open area to prevent GPS signal shadowing. RTK allows you to plan highly detailed missions with short capture distances down to 2 meters, while regular GPS navigation makes it dangerous to fly closer than 10 meters to the surface. One battery provides for capturing approximately 400 photos. Make sure you have enough batteries according to the size of your object and target level of detail. 2000 to 3000 images is a typical number of a detailed dataset. Power up drone and establish connection with RTK base station. Don't forget to save coordinates of base station in the application settings for consistent navigation between base station reboots on battery switches. Use a drone app to create an overhead flight plan and launch the mission to capture images for rough geometry reconstruction. To capture vertical and concave surfaces, you'd better use an oblique photogrammetry survey preset in your drone app instead of taking only nadir photos. Select sufficient altitude to avoid all obstacles you've noticed during the site inspection step. Oblique preset generates extra missions to capture object under varying angles to addition regular nadir mission. Before starting the mission, make sure that the space above the drone is free. Always keep direct eye contact with the drone to ensure safe flight. The drone is performing nadir flight, taking only vertical photos. Now it has switched to the oblique flight and is capturing objects from 60 degrees angle to the east. Now all the nadir and oblique subtasks are performed and overhead flight is complete. Import captured photos into Metashape to build a rough model of the region of interest and generate a detailed flight mission. Import photos into Metashape using Add Photos or Add Folder command, in case overhead flight imagery is stored in separate directories. Align photos to estimate camera position and orientation for each photo, and generate sparse point cloud consisting of type points. Use generic preselection and reference preselection source for faster processing. Use BuildMesh command to generate a rough 3D model of the region of interest. Use depth maps as a source data and medium or low quality to speed up the process. If power lines are present in the scene, use Detect Power Lines tool. Several shape layers with polylines will be generated. Select the layer where all the power lines are detected. Along with the power lines, other linear structures can be presented as shapes. To clean the layer, select polylines of interest and move them to a new shape layer. Add approximate takeoff point to the layer. It will be used as altitude reference for waypoints. Select Polygon tool and draw the region of interest and save it to a new shape layer. Outline no-fly zones and save corresponding polygons to a separate shape layer. Open Plan Mission dialog. Specify region of interest. Set capture distance according to target resolution. Provide safety distance, which will be used as minimal fly distance to surface model, power line shapes and restricted zones. Please note that capture distance can't be less than safety distance. Select shape layers corresponding to restricted zones and power lines. Set home point and minimal altitude. Typical values for safety distance is 2 to 3 meters for RTK drones and 10 meters or more for regular GPS drones. The resulting plan will be split into parts according to max waypoints per flight setting. Here's how the full plan looks like. You can see how the planned path bends over power lines. To execute the mission, select other parts and export them in one of the available formats compatible with the drone software. In this project we are using KML format, compatible with the DJI Pilot application. Import generated mission files to a drone application and execute one by one. Always keep direct eye contact with the drone to ensure a safe flight. Do not fly during strong geomagnetic storms due to possible issues with positioning. And also keep in mind that GPS shadowing and signal loss can occur in concave regions of the building. If the drone battery gets low during the flight, replace it. Restart the drone at the home point and manually navigate it to the last visited waypoints. Here is the final model built from detailed images. Thank you for your attention and good luck in flying!